And I apologize for starting late.
Oh, yeah,
Yeah. It's always my fault. That's the one thing I do know. So, Smalltalk is a vision of the world as it should be. Not necessarily as it is, but the way it's supposed to be. And this talk is in that spirit. It is a vision of the world as it should be, as I think it should be. And of course, those two things are obviously the same. And some of this may strike some people as controversial, but then people never invite me to talk so they'll actually listen to what I say, but to stir things up, so that's okay. And you'll also find that I may make statements that seem fictional or exaggerated or whatever, but again, it is the world as it should be. So, friends, countrymen, Romans, distinguished guests, members of the royal family, representatives of foreign planets, it is a great honor to be here at this moment of triumph. So, as we all know, Smalltalk has won, and a new age, a utopia, is upon us. So the projector is not doing as well, but the idea is we're all going to be frolicking like these happy people right here. It's great. And the reason it's great is because Smalltalk is everywhere. It's on every mobile phone. It's on every device. It's Amazon Web Services, Azure, Google App Engine. Everything runs this everywhere, and rightly so, because it's better, right? So the question is, at this moment of triumph, we should reflect and ask ourselves how we got to this position where our software really is so successful all over the world. And it begins with this lovely machine, of course. And in fact, if things were as they were supposed to be, yes, we would have versions of this machine running everything from the hardware up. But we still managed to dominate. And we did that despite the fact that this machine and the system on it had flaws. It's as close to perfect as anyone has ever done, perhaps, but it still wasn't perfect, and there were certain weaknesses. But fortunately, the Smalltalk community doesn't rest on its laurels. It is always willing to try new things and move into the future and try the best thing. And it doesn't, unlike other communities who tend to get stuck with their old way of doing things, Smalltalkers always move forward. So one of the problems that Smalltalk used to have, but thankfully doesn't have anymore, was this issue of conflicting dialects, right? And this means that, development effort is if not wasted, it's less effective. You can't take advantage of things that people have done on another dialect and so forth. But fortunately, we realized all this and came together to define a common language. And one of the issues here really was that the vision of Smalltalk was very unusual because Smalltalk was never a programming language, it was a programming system. And as such, it didn't actually have a language for expressing entire programs. There is no way to express a class as a linguistic construct. There is certainly no way to express a complete program, there isn't even a concept of that textually, right? There is this sea of objects that living and going, and that's a very powerful perspective that gives Smalltalk some of its great strengths, but without a notion of language, it was not complete. In fact, what Smalltalk did was this really clever hack, but it is a hack, and it's important to recognize that, which was that we basically, yes, a class just happens to be this object that knows how to make other objects, and you send it this reflective method call, and it'll make you instances or new subclasses and so forth. And in these early browsers, these primitive browsers that were built, they were brilliant in their time, right? This is a slightly updated version of the one that was done in 1976. And of course, we wouldn't dream of using such a thing 40 years on, even though it was a very good design. And it capitalized on that. But we realized we need a notion of language. That actually, the view that much of the rest of the world took, that programming is about language and text, while it is incomplete and broken in its own way, I saw you guys. Yes. So obviously, the view of a program as a piece of text is flawed. And the view of the program as just the side effects of some sea of object interacting is also flawed. Both of these are incomplete. Fortunately, we realized this many years ago and came up with an actual textual syntax for Smalltalk, right? Because that's not a bad thing. And since we had such a textual syntax, then of course some things became really easy, like interacting with source control systems, right? And so we built these nice tools that would let us interact with source control systems. Of course, not at the level of the horrible command line sort of stuff that Linus and his ilk invented. I did not know about Dale's talk when I prepared these slides, right? But obviously I think it's really good that we're looking at these issues. There is a difference, I think, of opinion about how to go about it. But they made the mistake of giving me the keynote, so you're stuck with my comments for now. So, right, so it becomes very easy to do these kind of things, and of course we didn't do that also at the level of raw text diffs like it does, right? We have a system that will show us things like which classes were added, which methods were added, which methods were removed, etc. in a structured form in the Smalltalk environment. I don't know if you guys can see this, Scott. It's horrible up there. Okay. Yeah, well, yeah, so you see there, yeah, oh, it's really bad. Oh. Okay, you can't see it. You'll never be able to see it. Believe me, it's there. How do I get this? Here, let me stretch this out so it's straight and focused. Right. So that, of course, was one problem with different dialects. But, of course, we had this problem of differing libraries, which is actually a much harder problem, right? And our libraries the situation with the libraries was a bit of a mess, right? We had frogs and fish among our libraries, whatever. But we came together and solved that too, right? We realized that the benefits of having a standard that we could agree on outweighed, whatever potential there might be for benefits especially to individual vendors. Let me see if I can offend some more people here. Right? That things like vendor lock-in or whatever were not really, a bigger pie was of benefit to everyone. And so we got over that. So fortunately, we don't have these problems anymore. One of the libraries that was most difficult to deal with was the whole library issue of reflection. As we saw back in the day when we used the reflection API directly to define our programs, we had horrible problems of converting from one dialect to another. But once that was gone, there was still the issue that the reflective API that had originally been done in Smalltalk was brilliant. It introduced the whole idea of reflection in object-oriented programming in a very natural way, but was actually sort of naive. Because what it did is it mixed base-level programming and meta-level programming. It confused them. So if you have an object, like a shoe, and you ask for its class, well, you find out that it's a sneaker. That's great. But these objects, these class objects, they're playing two roles. They're playing a base-level role, where the class is an object that you use to manufacture new objects, to construct new instances. And they're playing a meta-level role, where the objects where you can ask them what methods exist in the program, who's the superclass, what fields there are, etc. And so this architecture was replaced with mirrors, invented originally by David Unger and Company for Self, and then brought into the Smalltalk world, actually sort of simultaneously, both by Alan Worfs-Brock, who didn't call them mirrors, but actually gave a talk some 20 years ago, almost exactly, at UPSLA 96, that was basically about the use of mirrors for distribution, and in Strongtalk. And of course, we've long since realized the benefits of this, and we use this arrangement, right? So there, you have base-level objects clearly separated. You get mirrors on them, and mirrors are objects that work at the meta level. And so if you ask you get an object mirror and you ask for its class, you get a class mirror on the class that was the class of the object it's reflecting. But you could also ask for reflect directly on on that class and get that class mirror or an equivalent class mirror. So we clearly separated the base level and the meta level, and that has all kinds of advantages for deployment, distribution, security, etc., etc. In particular, distribution, right? Because the nice thing about this is, right, when we have a situation where we have an object, like this old woman who happens to live in a shoe, and there is the problem that one might ask, well, what shoe, right? This is a fairy tale, so you can see the kid, his parents are reading the story, and the little girl asks, Mommy, but what kind of shoe? The kids get obsessed by specifics sometimes. They will, shoe, it's a vague abstraction. We want to know exactly what kind of shoe. And so you ask the shoe what its class is, and you're doing this remotely because it's a faraway place. It was long ago in a faraway land, so it obviously is a remote situation. And the mother says, she lived in a proxy, dear. So that's what happens when you don't have this separation, because the question of what class this shoe proxy is ambiguous, right? It is a proxy object. And you have to understand that you actually what you want is, the answer you want in this context is a proxy for the original class, right? And mirrors let you do this. And it was good that we adopted this early on, because, for example, when mobile came along, we were in this fantastic position where we could set up remote access to the phone and do development on the phone from our nice programming environments with almost no work at all, because we were already running images that could manipulate other images, right? So we had carefully designed our mirror APIs to allow for the case where, it wasn't always local. And so we moved into mobile and had these fantastic development experiences almost immediately, which is one of the huge advantages which brought us to our current position of dominance. Now, another thing that we found early on was that, because the world had gone wrong early and not realized that, Smalltalk should be running directly on the hardware as the operating system, that they had their own windowing systems and their own things, and people responded badly to that because it looked different. People generally respond very badly to things that are different. They don't like different. It's an unfortunate property of people in general. And so we realized early on that we should have portable, portable UI is great, but we should be able to bind to native stuff, right? So here's an example. This is actually, again, something that's talking about source control, and here's a workspace, but these run natively, and they should, they run natively on all the platforms because, between the community we had adequate resources to do all these bindings, so we weren't stuck, for example, only on Windows when we did these things. Another thing we realized is that the tools should evolve. As I said, we wouldn't dream of using the 40-year-old design of a browser anymore. And in fact, we realized that it was actually in many ways very convenient to work with navigation-based UIs. And this fit perfectly in with the web, and fits perfectly in with the way people actually control the UI of their phone, because it's always the sort of thing that you go back and forth and so forth. And so we had these new environments, and we evolved our tools to, so you could go back and forth and maintain things, and you cured this plague of multiple windows that you had to manage and so forth. And again, we were always ahead of the curve because these ideas were quite clear ahead of time, and we never, got obsessed by, unlike other communities that are sticking to their things. Like you hear these people who are used to programming with curly braces and they can't get used to Smalltalk, whatever, right? But Smalltalkers, they can move on. They're not stuck on anything. And of course, these native UIs all relied on the ability to interoperate smoothly with the environment. And that's why, the early Smalltalks, being designed to be the only thing running on the machine, didn't necessarily have great ways for calling out to the rest of the world. We had all kinds of clunky primitive syntax and things, and these things weren't necessarily very portable. But we realized that basically these objects, these things outside of Smalltalk, they're objects too. They're second-class objects, let's face it, but they were objects. A.out was an object, and a DLL is an object. It happens to be an object that expects the operating system to call it with a main method and start it up, right? That sort of thing. We realized all these things, and we basically had this concept of alien objects, right? Like this one, right? And I'm not going to actually, it's quite interesting what this is saying, or so I'm told. I don't actually know what it's saying, but I believe the people who told me what it's saying. But that's for another discussion. And so, yeah, we didn't need these hacky things like the primitive syntax, right? Because it was primitive. Because really, there's two. First of all, we realized that primitives and foreign function calls were two different things, because many people have confused them in the past. But we also realized that for most purposes, we didn't need like things like VM plugins and stuff, because the primitive you need is the foreign function call. Then you can call everything that's outside. And actually, VM functionality that you want primitive access? Well, that's what mirrors are for. We have the VM mirror, so we talk to that. We talk to everything through an object. There are no weird special cases. We always knew that everything was an object, and a few places where there's sort of oversights, we got over them a long time ago. Now, another issue going back to this issue of language, so how is an object like a fish? The view of the sea of objects is very powerful, but it also interfered with our ability to move things. Because if you have seas that are disconnected, you have like these landlocked bodies of water, and if you have to move an object or a fish from one of these to another, they don't do too well. It's not that easy to move them, because fish and objects live in an environment, in an ecosystem. And they have other fish that they're connected to, or objects as the case may be. And if you want the fish to be transferred and survive, you have to bring its friends. And you start fishing and pulling, and you don't quite know when to stop. And it gets rather tricky deciding when to cut off the network of fish. And so the sea of objects isn't really great for transporting things. I mean, there were efforts. Dave Unger did the transporter, but it really isn't an answer. This is where one of the areas where having a syntax for the language helped, because then we could, at least we had the code very easily to separate. When we actually needed to separate an application, that got more complicated. So that's also an issue we had to deal with, and dealt with a long time ago. So deployment became easy because, again, we realized that an application that we were deploying was also an object. And all we had to do is create the right object and serialize it. And then when we wanted to load it and run it, we just had to deserialize it. And so we found recipes for building such objects, and of course it helped that we began to take modularity seriously, and realized that we could use the concepts of classes and objects to solve our distribution and modularity problems, and we did not need extraneous concepts like packages, because it's all a matter of grouping things together, and we already have a mechanism for grouping things together. So using nested classes and such. In fact, this one doesn't even use them, but some do. We know what we do. We basically have to create an object that hangs on to all the code objects that we need. And since we were smart enough to ensure that our classes were stateless, the serialization doesn't bring in the whole world with it, right? Because these things don't have much state. It's very easy to cut it off. And then we have an object that has all the code pieces, and it has the main method that we need to execute when we start it up, when we deserialize it, and we have a deployment story. We also, now this is where the eggs will really come out, we realize that types can be useful at times. Sometimes we don't want them. We certainly don't want them telling us how to live. But once you have a linguistic view of things, you realize, yes, it sometimes is useful to be able to statically reason about your programs. There are cases where this is useful. When you're trying to minimize the size of your program because of the pressures of deploying to the web or mobile, extra information helps. It helps in all kinds of ways. And we realized that we could do this optionally. We could have pluggable type systems, so we could have multiple analyses that didn't conflict with each other. Of course, none of this ever affected how we ran our programs. That is the key thing, right? They're completely optional. They didn't change the semantics, unlike most programming languages. So, we were always leading in these things. So, long before TypeScript, for example, adapted optional types, we'd been doing this for many years. And of course, as I said, we learned to deploy to the web early and to build complete programming environments with all their features running in the browser long before anyone else, so that when this topic was hot, we were there with a working solution rather than following other people who eventually started to build such things.
Wait. I didn't take a picture.
What picture of what?
Yeah, you got it.
Okay, right. So, as I said, we never let the IDE get stagnant. We never decided that the tools were pretty much fantastic in 1980, and there's really not much that needs to be done beyond that. We realized that liveness was one of our strengths, and again, there were oversights and weak points in liveness in the old environments, because class browsers actually trafficked in dead code, just like text editors. When you looked at a class in a class browser and you looked at a method, there was very little you could do with that. The only things you could actually evaluate in most of these in those views were static things like globals and class variables, which of course we had long since eliminated because we knew that globals were an idea that were in vogue in 1976, but really people realized that was a problem, and people realized that static state was a problem. So we got rid of this because we had good modularity solutions. But we realized that we want to be live always, that we never want to look at dead code. So our environments evolved to the point where we could actually get exemplar values for anything that was mentioned in the code while we were looking at it. And that was actually a challenging problem. But, you could get this data from tests. Smalltalk community invented unit testing. You could get it from types when you had them, or if you didn't have types, you could infer the types from these live values if you had them. There are all kinds of this information flowed in multiple ways. And we've recently started to think about how we can use, machine learning and stuff to infer some of these things. So we got an environment where you never had to simulate something in your head without any data, without any actual objects. And so, that was one view. Here's a view in a class browser, which obviously isn't the original class browser. And so we had the way coolest environment you could imagine. Then there was a small matter of performance, right? And harnessing the power of computers in non-destructive ways was a challenge. But we had been doing JITs for a long time, and had very high performance ones for years. And we took advantage of that early on. We didn't let that slide. And one of the advantages when mobile came along, and we found that, for example, Apple wouldn't let us use the JITs, right? But we already had techniques for that, because early on we had realized that one of the problems with all these dynamic jitting techniques was for clients was that there was warm-up time. And so we had systems that would actually go through training sessions, have a database of compiled methods that had already been compiled, and were ready to apply them instantly on startup. So, the next step is, deploy that and turn off the JIT so that you basically are not jitting on the Apple machine, and yet you have the compiled code. Sure, the dependencies tended to creep in because people hadn't really anticipated that before, but the basic mechanism was there, so we actually could get high-performance stuff long before people got into the current vogue for AOT, right, for ahead-of-time compilation and so forth. So, performance was not a problem. It just took that fantastic foresight that the community has. Because, of course, we had this slogan to inspire us, right? Of course, even this is not perfect. Because what happens if you don't invent something, then how do you predict it, right? So they didn't invent cybercrime in Xerox PARC, and therefore they failed to predict it, and they built a system that is a cyber criminal's dream. Everything is open, everything is accessible. You have one instance of an object, hooray, now I can not only corrupt that, I can corrupt all instances of that class anywhere, right? It's a recipe for security, but it's an unusual one, an acquired taste, shall we say. So, but we were fortunate that the basic ideas of objects were so solid and so general that we could capitalize on that. right? There was the capabilities had been around even before Smalltalk, but objects and capabilities just were such a natural fit. The object capability model that Mark Miller developed, actually in the 90s, but he got around to getting someone to sign a PhD for him in 2006, long after he was a kind of famous researcher, just, took advantage of the fact that the capability you want is an object. If the only thing you can do is a message send, then the only damage you can do, the only effect you can have is through a message send, and you can only do that if you have an object to send it to, because there is nothing else. There are no other operations except message sends. And so having what set of objects you have defines what you can do and what your powers are. And once you do that, you realize again that you don't want static state and you don't want global things, because those constitute ambient authority. Those are things that are floating out there. You think it's a good idea to have some standard set of things in the language like files, and you put them in some public place, and then it turns out that sometimes you don't want people to be able to access the file system. And so you don't want anything global. But we knew that. And so the only thing we needed to add was to actually enforce access control to make these real capabilities. Because in Smalltalk 80, objects encapsulated stuff, but according to two very, very simple rules. One is that, they encapsulate their variables, but anything that's a method is computed and is public. And as long as you're not worried about security, there's still software engineering concerns, but basically you tell people, oh, this is a method, but please don't use it. I don't really mean for this. And we put conventions and say this category is private or that. But that didn't really work. If we especially when we didn't want people to ever access fields for all kinds of software engineering reasons, and we made everything a message, and all messages are public, then that's kind of broken. We realized we needed an access control model so we could decide which messages are for the object itself to use and which are for the public to use, and which are only to be localized for software engineering reasons in the class. So we had a model of public, protected, and private messages, but of course it's all dynamic by the VM. It's not like we copied the stupid model from, well, I don't want to mention any names. So then we had essentially an object capability method, and we had, security is a multi-layered thing. Yes, we heard today about crypto libraries. There's all this stuff. You have to do reviews, whatever. But we had the foundation in the language for building this on a simple, uniform basis, right in the core of the language. And so we could write our code like this, and we could make things private if we wanted to, or public, or if we said nothing, then protected, which basically meant object-only access. Then, we were very quick to jump on the latest, hottest opportunities. Right? This is one of those pictures that Google Brain does by reversing the neural nets that were supposed to analyze pictures and then synthesizing stuff, and it's truly scary stuff. But a lot of that is using TensorFlow, the framework that Google put out, and that framework was designed so you could put front ends on it from different languages. And so, of course, the natural choice for that front end was Smalltalk because it was so popular and successful and well known. No one would dream to do it with some sort of hacky scripting toy like Python. And machine learning had other possibilities for us. We started to incorporate it in our live programming environments because there's cool things you can do. You can start inferring things from the live data, from traces, what's going on, and try and figure out and predict what results they'll see or what they're going to do. And we were on top of that because we're always in the front. And of course, there was the small matter of debugging, right? So we had this wonderful idea that the image was a searchable thing, right? That we could go through and find any object and manipulate it. But that was a sea of objects at one point in time. But we wanted to do underwater time travel. We wanted to travel through the sea of objects into the past and see when something went wrong. And so we took the lead on that because that, again, is a feature by itself that is worth 1,000 conventional language features. And so we got that done, and, it didn't really matter when we got it done, it's true. And finally, Smalltalk had these ideals of education from day one. And they're very important. But the thing is, at some point we realized that the naive idea that you'd educate people with this cool stuff and then they would continue and spread the word, that wasn't enough. I don't know if any of you have raised kids in a country where the language is different from where the parents were raised, but I've talked to a lot of people who have, and very typically you find at a certain age, the kids understand what you're saying, but they start answering back in the native language of the environment. That's because they have a real sense of where the action is. They know the environment long-term for them is actually more important than what their parents are saying. And so they tune in to what's happening around them. And you can teach kids, squeak and stuff at an early age, and then at some point something goes terribly wrong, and they say, oh, I want to use, C or JavaScript for the web or whatever, like everyone, so I can have that power over and do what everyone else is doing. Right? Fortunately, we short-circuited that because of all our previous successes. We didn't have this problem. So in fact, the Smalltalk message, we have people coming to us who want to do MOOCs for Smalltalk. What are they called? Massive online courses, right? For education over the internet, right? So all these sites that are doing this, of course, they support Smalltalk first because that's the new hotness. And of course, we also had great documentation materials and stuff because we always did have this idea of combining, that our text models weren't as primitive as text editors, that we could put live widgets embedded in text long before the World Wide Web was doing this, right? This was done in the mid-90s before web pages were anything but gray kind of Netscape lists of things. Right? This was done before JavaScript existed. And it has probably been done multiple times before that in various ways. So yeah, you could write a document and it would have live browsers in it. And for example, this collection browser here, you choose to open it and it all interacted. And all in a native widget where you could, easily decide to get a nicer font or the full Unicode or any kind. Everything just got supported for you by the environment. And of course, it still works on the web today, and we have these rich environments that do this. So, and therefore, it's a natural choice for people to use. That's why so many millions of programmers use it everywhere. So, in conclusion, I think the key thing, the common thread in all these things is that the Smalltalk community never got complacent, never thought that because they're 30 years ahead of their time, they can just, kick up and relax and the world will not catch up with them or that there weren't weaknesses that bothered other people, right? They might not bother the people in this room, but there are many things that were a problem for other people, but we solved them anyway because we looked at all this reality and worked on it. I'm beginning to feel odd. So it's just this nightmare that I get that imagine if the world wasn't like the way I described it. Can you imagine, this horrible thought came to me, think if one of the world's largest, internet providers, internet sites ran on PHP. We all know Facebook runs on Smalltalk, that's why they're so successful, but it would surely have failed, but just think for a moment about the nightmare, right? I don't know, the drugs they're wearing off. Maybe this is the world, right? Let's see. I think there's PHP right there, I don't know, but we should never give in to these fears and nightmares, right? It's going to be okay. It's going to be great. Well, sorry. Yeah, more drugs, yes. So, that's actually, I didn't have that much to say. So there we are.
Thank you.
Turn this on.
Sir, I have one question.
Hey, do you want to say something?
Yeah, I'll take another shot soon. I'll just inject.
I'm very amused by this
Questions?
It's obvious. Told you. Hey, think of it. We can get back on schedule.
Why are you hypothetically this utopia? Are you king of the world now?
Well, obviously, I mean, let's see, I turned this off, or whatever. The fact that the world turned out in this wonderful way is good for all of us, right? Because we were early in on Smalltalk. Well, not for you. You're just a student. You're just having to compete more for positions in the Smalltalk industry where everybody's trying to get in. It might be tough for you. But the older people, we're well established and we're just raking in the consulting fees and all that from all the people who want to know it, right? So no, I'm not king of the world, but yeah, I mean, definitely it is no coincidence that many of my ideas figured so prominent here. As I said, this is the world as it should be, and what could that possibly mean except the world as I expect it to be? So I don't understand the question. Of course it all fits.
Okay, thank you very much.
Well, I hope it was amusing. Nothing else. Yeah, let's